Energy, endothermic and exothermic. Introduction. What do you think of when you think of energy? In chemistry, energy is the capacity to do work, such as moving an object or increasing the temperature of an object. This definition applies for the scientific fields in general. Here are some common forms of energy: electrical, mechanical, thermal, chemical. In this class, we'll focus mostly on thermal and chemical energy. So when you think of temperature, you most likely think of how hot or how cold something is. This is actually inaccurate. Temperature is the amount of motion in the atoms of a substance or an area. More motion of those atoms means a higher temperature. Heat is the amount of energy in the molecule's motion. Different substances at the same temperature may have different heats because of their molecular energy. Because heat is energy, we say it can flow between bodies. This means that you can transfer it between different objects. You can think of atoms as the little green balls. Lower movement will mean less temperature or lower temperature for the atoms of a substance or object. Higher movement of the atoms of a substance or object means a higher temperature. Heat flow is what causes you to feel different temperatures when you touch objects. Another common misconception is that the feeling of cold is flowing into you or out of an object. Cold cannot flow. This is how we interpret heat leaving our body. When you touch an object and it feels cold, we say that heat is leaving our body. Alright, to talk about heat flow, we need to establish terms to discuss what we're going to be studying. A system is what we are studying. It is usually a very specific item that needs to be stated. The surroundings is everything else that we are not studying. Usually we will focus on the immediate surroundings, what is right around our system. For example, a hand touching it or the table it sits on. If a system is endothermic, this means that energy is going to be flowing into the system from the surroundings. The temperature of the system will increase after time because it's gaining energy. This does not mean it feels warm. In fact, there may be a cold feeling when you touch it because heat leaves your body and goes into the system. Some common examples of an endothermic system are frying an egg, melting ice, and evaporating water. When something melts, boils, or evaporates, this is also an endothermic system. Remember, in an endothermic system, energy is flowing into the system from the surroundings. Therefore, the surroundings will feel colder. If a system is exothermic, this means energy is flowing out of the system into the surroundings. The temperature of the system will decrease over time because the system is losing energy. This does not mean the system will feel cold. The system may in fact feel hot because it is releasing energy. Some common examples of an exothermic system are condensation on a drink, water freezing, and burning a match. When an object or substance freezes, condenses, or burns, this is an example of an exothermic reaction. Remember, if the exothermic system, in an exothermic system, energy is flowing out of the system and into the surroundings. Therefore, the surroundings will feel warmer. All right, here's some practice. For each of the following, we'll identify the system as being endothermic or exothermic. An ice cream cone melting in your hand. A burrito in a microwave. Boiling water. A log burning in a fire. The first scenario involves an ice cream cone melting in your hand. The ice cream cone is the system, and it's taking in energy from the surroundings. Therefore, this scenario is endothermic. The second scenario, a burrito in a microwave. The burrito is the system, and it's taking in energy from the microwave. Therefore, this is an endothermic system. Boiling of water. This is also an endothermic scenario. The water requires energy in order to boil. Finally, a log burning in a fire. The log is releasing energy into the surroundings. Therefore, this is an exothermic situation.